Hey everyone, welcome to homework 5.4. I have a really bad headache and I'm filming this at home, so you might hear some background noise, and if I make any mistakes, you can get some extra credit if you point them out to me tomorrow, or Monday rather. See? Already. Okay. So today we looked at factoring quadratics from standard form to factored form that had different signs. So if we are starting off here, we are finding two numbers that multiply to -40 and add to equal -6. Well, since we're trying to get to -40, we know that one has to be negative and the other has to be positive. And since it's -6, that means that the negative number is going to be bigger. So I'm going to write out factors of 40. 8 and 5, 20 and 2, 4 and 10. Let's see if we're missing any. Looks pretty good there. And then one has to be negative. So if we want them to add to be -6, if we do this, that would be -3. This would be -18. This is going to be -6. So my factors here would be 4 and -10. 4 times -10 is -40, and 4 plus -10 is -6. All right, so the next one is multiply to -40 and add to +6. So looking at what I just did, I can just change this and make the 4 negative. And so then -4 and 10 will be -40, and then 10 minus 4 gives us +6. Multiply to -36 and add to 9. So let's come up with factors of 36. We have 12 and 3. We have 9 and 4. We have 18 and 2. Okay. And so now, and we have 6 and 6. So we're going to add to be +9. Again, we have -36, so one has to be negative. And in this case, because we want it to be a +9 when added together, we want it to be a smaller number. So 12 minus 3 is +9. That looks pretty good. Let me just double check. 9 minus 4 would be 5. That's too small. 18 minus 2 is 16. That's too big. 6 minus 6 is 0. So it would have to be 12 and -3. Because 12 times 3 is -36. 12 plus -3 gives me +9. Now here we're doing multiply to -36, and we want to add to -5. So in this case, right, if I were to change the sign like I did on the previous one, just make this -12 and +3, that's -9. So it's not that set of factors. And so instead, let's take a look at the next one. We want it to be negative. If I were to make it -9 plus 4, that is in fact -5. So -9 plus 4, or -9 and 4. -9 times 4 gives us -36, and -9 plus 4 gives us -5. All right. Number 2 says create a diagram to show that x minus 5 times x plus 8 is going to equal this here. So I've created the diagram for you. You can fill this part in. You have practiced this enough that you should be able to do that without Miss Lee's help. So you can go ahead and complete that. Just be careful with this negative sign here. All right, number 3 says to write a positive or negative sign in each box so that the expressions on each side of the equal sign are equivalent. So what we have over here in factored form, we want to equal over here in standard form. So at the end of this one, I have a -54. And I have a -15x in the middle. So I want whatever I'm adding to equal -15, and I want whatever I multiplied equal -54. So 18 is bigger than 3, and I want it to be an overall negative answer, so I'm going to make this -18 and then a +3. -18 times +3 will give me -54, and -18 plus 3 will give me -15. Now, in this case, I have a positive and a positive here, and so I'm going to want both of these to be positive. A positive times a positive gives me a positive, and 18 plus 3 is 21. In this case, I have a negative and a positive, So I want one to be negative and the other to be positive, but this time I'm going to switch which one is which. So I'm going to make my 18 positive because 18 minus 3 will give us positive 15 here. And then last but not least, we have a positive and we have a negative here. So this positive here and this negative here means that both signs this time have to be negative, because negative 18 times negative 3 gives me positive 54, but negative 18 plus negative 3 gives us negative 21. Number 4, match each quadratic expression in standard form with equivalent expression in factored form. So we're going to look at signs here. Let's start. This first one has a negative and a negative, right? So that means I'm multiplying a negative times a positive, and I want the negative factor to be larger because I want to create a negative sum when I add them together. So that eliminates number 1, it eliminates number 2, it has to be 3 or 4. Well, 3 has a positive 5 and a negative 7, and 4 has a negative 5 and a positive 7. So my best match here is 3. And if you want to check it, we would get x squared minus 7x plus 5x minus 35. This right here is where we're going to get that negative 2x sum. And so that matches with 3 and A. 12 is a positive and a positive, so I want there to be a positive and a positive. So that matches very nicely with 1. C has a negative here and a positive here, which means I need a negative and a positive. And so that will be 4. And we know that 7x minus 5x will leave me with this positive 2x here. So that looks good. And then last but not least, we can reason by process of elimination, that's the last one, but also negative 5 times negative 7 gives me positive 35, and negative 5 plus negative 7 gives me negative 12. Number 5 says rewrite each expression in factored form. If you get stuck, try drawing a diagram or write out your multiple factors, okay? So here I have a negative 28, and inside the parentheses I have a negative. That means one of them is going to be negative and the other is going to be positive. Now 28 has several factors. I have 14 and 2, I have 7 and 4, I have 28 and 1, right? But to make negative 3x, I want 7 and 4. So I can make this negative 7 plus 4. Negative 7 times positive 4 gives me negative 28. But negative 7 plus 4 gives me negative 3. Let's try the next one. So I'm going to do x, x. And again, I have a negative. This time I have a positive in the middle. So again, one's going to be negative, the other's going to be positive. But this time, my smaller number is going to be negative, and my bigger number is going to be positive. Because now 7 minus 4 gives me 3, and negative 4 times positive 7 gives me negative 28 still. Let's try our next one. Our next one has a negative here and a positive here. So again, we're still going to have one that is negative and one that is positive. In this case, though, we cannot use 7 and 4. 7 and 4 equals 11 at best. And so we're going to now be looking at 14 and 2. But again, I want my 12x to be positive, so 14 is going to be my greater number, my positive number, and 2 will be my negative number. Because negative 2 times 14 gives us negative 28, and negative 2 plus 14 gives us positive 12. Let's look at our next one. So we have x, x. Now this time, this is different, right? It's a negative, so still one's going to be negative and one's going to be positive. However, we have a different number to work with. So we want to think of all the ways that we can make 60. So I can make 60 with 2 and 30. I can make 60 with 10 and 6. I can make it with 15 and 4. But I want it to equal negative 28. So 2 and 30 is going to be our best bet. So we're doing minus 30 and positive 2. And I know this because negative 30 and positive 2 gives me negative 28. But negative 30 times 2 gives me negative 60. So again, when you're looking at your C value or your constant value, find the factors first and then use those to determine what goes in your parentheses. All right, which equation has exactly one solution? This is a multiple choice one, so I'm going to let you decide this on your own. You need to do this one by yourself. You can 100% find the one that has one solution. So number 7 is a review of functions. It says the graph represents the height of a passenger car on a Ferris wheel in feet as a function of time since the ride starts in seconds. Find h of 0. So h of 0 would be here, and it looks like these are going by 5, 10, 15. So this would be 5, and it's feet. Does h of t equals 0 have a solution? Explain how you know. So this is saying, is there a time where the height is 0? So if we look here, there's no place that it crosses the x-axis. So no, because it never touches the x-axis. You could say there's no x-intercepts. You could say that y never equals 0. Describe the domain of the function. So the domain is from 0 minutes to infinity, right? Here on the graph it shows to 60, but this could presumably be going on and on and on. If the Ferris wheel never stops. If the Ferris wheel only lasts, a certain number of hours, or it can only go for a certain number of hours, then you might be able to limit it. But based on this information in this graph, 0 to infinity. The range is from 5 feet to our maximum height here looks to be 55 feet, just under that 60 mark. Oop. Okay, there we go. Oh, that's weird. Okay, well, that's what it is. All right, let's take a look. So that should be from 5 to 55 feet. All right, Elena solves this equation, x squared equals 7x, by dividing both sides by x. So this is what Elena did. Elena said x squared equals 7x. She divided both sides by x. This is now 1x, and these x cancels out, so she got x equals 7. Lynn rewrites this equation and says x squared minus 7x. So she has x squared equals 7x, and what she did is she subtracted 7x from both sides, and so she got x squared minus 7x equals, this cancels out, 0. And she said, well, I know that this then has x-intercepts at 0, 0, and 7, 0, so the solutions are 0 and 7. Who do you agree with? Well, if I were to factor out Lynn's equation, I would have x times x minus 7 equals 0, which means that x could equal 0 or x could equal 7. So I agree with Lynn. And you can show how you know by doing this. In general, too, you don't want to divide by x. Like, that's just not a good practice. It generally isn't going to give you what you need fully. You can also say that x squared equals 7x. If I plug in 0, 0 equals 0, right? 0 times 0 equals 7 times 0. And if I were to plug in 7, 7 times 7 is 49, and 7 times 7 is 49. All right, number 9 is a review question. It is about our exponential functions. I know this is exponential because the exponent is a variable. It says the bacteria population P can be represented by this equation, where D is the number of days since it was measured. What was the population 3 days before it was measured? So I'm going to fill in 100,000 times 1/4, -3. -3 is 3 days before it was measured. Remember that negative exponent means before it happened or before it was initially measured. So you can calculate that in your calculator and find out what the answer is there. It says, what was the last day when the population was more than 1 million? So 100,000 times 1/4 D equals, to the power of D rather, equals 1 million. Right? When was that the case? Or more than 1 million? When was this greater than 1 million? And so in this case, I strongly encourage you to put this in the calculator, right? And look at your table and see when does that happen, all right? So I want you to do that and explain how you know. So based on what you see, when was this more than 1 million? I'm going to give you a hint that in order, since this is decreasing For it to be more than 1 million, it would have to be days before. And so here you should be looking at a negative exponent because you're looking at the days before it was 100,000. All right, number 10 is matching. It is matching factored form with standard form, and one has no match. So in this case, these are our differences of squares because we have plus and minus the same term. So one, the middle part's going to cancel out. So this will be y squared minus x squared. That's number 3. For this part, make sure that you are listening because I'm going to tell you them verbally. So x times x is 121, and then minus x squared, so b should match with number 1. C, on the other hand, would be x squared minus 121, so that would be 5. And then D will be x squared minus 2xy plus y squared. So that will be number 4. And the reason that this one is not 2 is because that middle value should be minus 2xy, and the last value is a negative times a negative. A negative y times a negative y gives us positive y squared. So 2 is the one that has no match, and D should match with 4. All right, number 11. Both x minus 3 and x plus 3 and 3 minus x and 3 plus x contain a sum and a difference and have only 1, 3, and x in each factor. If each expression is rewritten in standard form, will the two expressions be the same? Explain or show your reasoning. So if we multiply this, we get x squared minus 3x plus 3x. Hopefully you recognize that difference of squares there, and minus 9. This then is x squared minus 9. On the other side, though, we'll get 9 minus 3x plus 3x minus x squared. So this will cancel out, and I'll get 9 minus x squared. So they look very similar, right? But they are not the same. And the reason is this is a negative 9, this is a positive x squared, this is a negative x squared, and a positive 9. So our signs are different, and that will make a huge difference. If you plug in, for example, 1, you'll get 2 very different answers, right? You'll get either negative 8 or positive 8, and that is a different answer. So while these look very much the same, they are not the same, and you should write not the same and explain it's because of the signs. Number 12, show that the expressions 5 plus 1 times 5 minus 1 and 5 squared minus 1 squared are equivalent. So 5 plus 1 is 6, 5 minus 1 is 4, this equals 24. 5 squared equals 25, 1 squared is 1, that also equals 24. It's just mathematically we're showing this. This would represent 28 times 32, right? Those are the two numbers that are equivalent. And then if I wanted to rewrite this as a product of a sum and difference, I can rewrite this as 100 minus 6 times 100 plus 6. And that would also give us 94 times 106. It says, what is the value of that? So what I'm going to ask you to do is to solve that, right? So you can solve what is 94 times 106. It says, write each expression in factored form. If not possible, write not possible. So see here, we have perfect squares separated by a negative sign. So that means this is a difference of square situation. So x minus 12 times x plus 12. Here, we cannot actually do this, right? Because this is positive 16. There's nothing in the middle that would make this cancel out because it's a positive 16. So this one is not possible. Here, we have, again, the difference of squares, two perfect squares separated by a negative sign. So we could write this as 5 minus x times 5 plus x. Same thing for this one. We can have b minus a times b plus a. And then this one, like letter B, is not possible because it's not separated by a negative sign. So this is not the difference of squares. All right, number 14. What are the solutions to the equation? So for this one, you need to set each part. Remember, we're going to separate these. X minus a equals 0 and x plus b equals 0 and solve for x. So I would add a to both sides, and I get x equals a. That's one of them. Subtract b from both sides, and I'm going to get x equals negative b. That's the other one, so a and negative b. Number 15 is practicing your multiplication, your distribution, and your FOIL. So I'll set up the chart for you as I did earlier, but you can go ahead and show how that math works. And then number 16 says select all the expressions that are equivalent to 8 minus x. Remember, what's important here is that 8 is positive and x is negative, right? So here, x is positive and 8 is negative. That's not equivalent. Here, 8 is positive, x is negative. That is equivalent. Here, x is negative, 8 is positive. That is also equivalent. Here, 8 is negative and x is positive, not equivalent. This would be x plus 8, and so not equivalent because we don't have the negative there. So we x minus 8, nope, that is the opposite. And then negative x plus 8, yes, because we could rewrite this as negative x plus 8. All right, the last two are practice problems. And the reason I show you these is because they look super complicated, but they are not super complicated. So I want to make sure you are listening to this part because this will help you prepare for the park. Again, in this situation, we see a perfect square and it is being multiplied, right? The same values in the factored form are being multiplied, but with a different sign. So this means what we're going to get here is this and this separated by a negative sign. So this would be 1 minus r squared, right, times itself, so to the 4th power. And then this, what will happen is if we multiply the middle term and the last term, the inside term and the outside term, they will cancel out because one will be positive and the other will be negative. So the last thing that we can do is we can just multiply minus r squared. All right. Again, this is the difference of squares. This is like what we saw earlier with x minus 4 times x plus 4, right? We only need to worry about the first terms and the last terms because those middle terms, this minus 4x and the plus 4x, will cancel each other out. So that means our best answer option here is A. For part B, it's very similar, right? We're seeing something similar here, just a little bit different. But this part is the same. And then this part is the same, but they are separated by opposite signs. So if we recognize this as the difference of squares, we can rewrite this as 1 minus x. We're multiplying this times this, so it'll become to the 4th power. And then minus, and we're multiplying this times this, so 4x to the 4th power, and then adding plus 4x to the 4th power. Now notice here, these are like terms, so these will cancel out, and we will be left with just this right here. So our answer here is also A. It is 1 minus x to the 4th power. Again, this is just recognizing, you will see a question like this on CAPE, that these are the difference of squares. When you see something like this, don't panic. Look, this is the same, this is the same, right? This is the same, this is the same, but they are separated by a negative and a positive, which means that it is the difference of squares, and your middle term will cancel out. All right, that is it for your homework. Your code word for today is anthracite. Anthracite is your code word, and so if you spell that correctly, you can get an extra point. If you have any questions, you know how to reach out to me. Happy homeworking, and I will see you on Monday.